So once again, when we're looking at this flow chart to help us name these compounds, for today, I don't want you to do this on yours, but for today, I'm not interested in this right-hand half. That's about what we study in our next unit. So we go straight. We're going to start off by answering this question: Is the metal multivalent? Well, let's actually add to this what that word multivalent means. So just so we can fit everything in there, just really small, maybe in the upper left-hand corner. That's where I'm going to put it. I'm going to put the definition of multivalent. Scroll it up just a little bit there. Right up here in the upper part. I'm going to zoom in a little bit more on the screen. Yes, maybe right over there. Multivalent. All right, this indicates those metals that come in multiple charges. And that's going to include most of the transition metals. Not all, so we're going to find out which ones are not included. Most transition metals, that's the D block. Plus tin and lead. Group 1 and Group 2 are not multivalent because they always only have one charge. There's a few transition metals that are also not multivalent. So take out this pink list of your transition metals. The first one on there is silver. How many charges does silver come in? One, positive one. It's only got one option. It is not multivalent. What about zinc? It only comes in one charge. It happens to be positive too, but it's only one option for it. So it's not multivalent. So that's something we need to keep up with, because the first question we're going to ask ourselves, is the metal multivalent? And if the answer is no, so if the metal comes from group 1 or group 2, or like zinc or silver, also group 13 over there, aluminum and gallium, they only come in one possible charge. For those guys, they are not multivalent, so we go to that first flowchart option for no. And down at the bottom of each one of these, I'm going to give an example. So for instance, for our first one, if we look at a compound such as calcium CaCl2. All right, so if you had something like CaCl2, you look at calcium, it is not multivalent. So to name it, it's really easy. It's called binary ionic. Binary just means two different elements. That's the second question we would ask ourselves. How many elements are there? It's easy to find, guys. You just count the capital letters. Every capital letter is a different element. So this one has 2 capital letters. It's calcium and chlorine. I know it's just 2 elements there. So those are the easiest ones of all. So to name one like that, I would just name it calcium chloride. One thing to keep up with when you do name these on Canvas, you'll be typing in answers, and Canvas is very picky even with capital letters. The way we name these, you capitalize the first letter of the first word, and you don't capitalize the second word when you name them. So capital C for calcium, lowercase c for chloride. And like we know, you just change the ending to IDE if it's just the single element there, not polyatomic. All right, so then you can have another option. What if it is a metal that is not multivalent, but you count the capital letters or you count the elements and you have more than 2? All right, in that case, we could have something like strontium nitrate. So if I had something like SrNO32, first of all, strontium is also in group 2, so it's not multivalent. Let me connect my screen again. But when I count the capital letters this time, there are 3 capital letters. There we go. That means I have a polyatomic ion. The parentheses jump out a polyatomic ion as well. So check your orange list, find NO3. I accidentally said it a second ago. NO3. Nitrate, thank you. So for naming this one, we're just going to name it strontium nitrate. So they call this one ionic ternary. Ternary just means 3 or more elements, but for me, I just think of it polyatomic ion. Okay, so then we can also do these same options when we have a transition metal or a multivalent metal. We have to figure out which Roman numeral to use when that does happen. So we got to figure out what charge we're dealing with. I'm just going to scroll over now. If you ask yourself that first question, is the metal multivalent? If you say yes, you're still going to count the different elements like before to decide whether or not you have a polyatomic ion. This time, when you name it, you're going to name the transition metal first, but you need to leave a little space for a Roman numeral to represent the charge, and then you just put the ending with, say, IDE. So, an example of that one, I know your paper might be getting kind of crowded, so I'll just point to this one here. What if you had Fe2O3? In this case, you just have 2 elements, but one of them is multivalent. So if you wanted to check beforehand, you could check for iron. You find iron on here. Iron comes in 2 possible charges. Sometimes it's +2, sometimes it's +3. Well, the way you can figure out which version you're dealing with is look at what it's bonded to. All right, in this case, iron is bonded to oxygen. What is the charge of oxygen? -2, and there are 3 of them. Since there are 3 of them, that adds up to -6 total. Therefore, my irons need to add up to a +6, but I only have 2 of them. So if each iron were +3, that's going to add up to +6 on the positive side, and we would have -6 from all those oxygens. So ask yourself, what is it bonded to? Based on what it's bonded to, you can figure out the individual charge of the individual iron atom or whatever the particular metal happens to be for that one. All right, and so for naming that one, I'm going to name it iron. And then in parentheses, I'm going to put a Roman numeral 3. When you type that, that would be 3 capital I's when you have to do it on the assignment. And then, what do we put for oxygen? Oxide. So when you do have to put a Roman numeral, that's the hardest thing you have to do today, I think, is figure out the charge of the transition metal or the multivalent metal. And the final possibility could be that you would have a multivalent metal with a polyatomic ion bonded to it. So let's say for this last one over here, we had NiNO3. Now NO2, I want to do NO2 for a comparison. So that NiNO2, 2. We've got a multivalent metal And you count 3 or more capital letters. So you've got a polyatomic ion to look for. So for naming this one, once again, I'm just going to name it like the others, but I'm going to leave some space. Nickel, parentheses, and then for my last word, what is NO2? Nitrite, good job. So it's nickel something nitrite. Okay, I'm almost done. I just have like 1 more minute tops. So it's nickel something nitrite. Let's figure out its charge. So while you've got your orange sheet out there, find the charge of nitrite. What's nitrite's charge? -1. How many nitrites are in this particular compound? There's 2 of them. So -1, -1. Therefore, there's only 1 nickel. So what does the nickel have to be? +2, huh? Well, my pen isn't working, but there we go. So we put a Roman numeral 2 here. And there we've got the name of the compound. So that's the majority of what you're going to do on the Canvas assignment. It's going to give you a formula, and you will name it. Watch out for those little picky rules like polyatomic ions and multivalent metals, to use the Roman numeral there.